Hello, geometry students. How's it going? I hope it's going well for you. Today we're going to be covering the Unit 10 activity. It's based on applying probabilities. Let's get into the activity. If you're not here for Unit 10 activity, then you might be in the wrong place. Okay, but without further ado, let's get started. Okay, so let me share my screen with you real quick. Okay. All right, here we are. Okay, so go to the assignment. You should be here. In the introduction, you're going to need this report. So you see right here, it says take a look at this report, and you can click on it here. And that should open a report that has to do with air travel consumer report. You see that there. It's 44 pages long, but we're only going to be looking at some of the tables and stuff, okay? So we'll be looking at this later, but you could see it talks about different flight carriers, their probabilities of landing on time, and things like that. Okay. So with that, then go to page 5 here. Questions you can answer with the table. Okay, so the first question is this. Oh, and by the way, we need to refer to table 2 in the consumer report. So let's go ahead and find table 2. Okay, it's right here, table 2. And notice that table 2 actually continues for a while, right? So table 2 is pages 6, 7, 8, and 9. Okay, so we're going to be looking at those pages for table 2, and to help us answer, that'll be to help us answer the questions. Okay, all right. All right, question 1. Given that a randomly chosen flight arrives in Atlanta, what is the probability that it arrives on time? Okay, so basically, here's what we're going to do. We want a probability, which generally is a ratio. And in this case, we want to say, it says, given the randomly chosen flight arrives in Atlanta, so what is the probability it arrives on time? So on the numerator, we're going to put the number of flights that arrive in Atlanta on time. And in the denominator, it'll be the number of flights arriving, I'll put it the same word, that arrive in Atlanta. So these are the two numbers we basically need from the chart. Okay. So what's kind of key here is that it says, given that a randomly chosen flight arrives in Atlanta. So where it says given that, that's your denominator. So it says, given that a randomly chosen flight arrives in Atlanta, so our denominator is all the flights that arrive in Atlanta. Then the second part after that is what goes in the numerator. What is the probability that it arrives on time? So it arrives on time and it's from Atlanta. That's the numerator. Okay. Okay. So that's what we need to find. So on our chart, you could see on the left, it has the carrier. So who owns the plane, basically, right? So like the first one's American Airlines and so on. Then it has the cities across the top. Okay, so Atlanta's the very first one. Now, if you look, it has a lot of information. Like in American Airlines, there's 421 arrivals, and 86% of them were on time. Okay, but if you look at all the way at the bottom, it has the total number of flights. Oh, and it has the percentage that arrive on time. So they're already giving us the answer. What's the probability it arrives on time if it arrives in Atlanta? Well, 87.7% of them arrive on time. So 87.7 Why is it not typing? 87.7%. Is there a percent sign? Should be. I guess there's not. Okay. Then we could write it as strictly a decimal and put the decimal. Now they just gave us that answer, so I guess we didn't need to write this, but this is how it's calculated, okay? And this will come in handy later, so don't erase this, even though they just gave us the answer, okay? And that's it. All right, based on that, see if you could do part B. Given that a randomly chosen flight, US Airlines flight arrives in Denver, what is the probability it arrives on time? So I'll actually do this one with you also. So we want to look at the US Airlines. So we go down to US Airlines, just towards the bottom. And then we want to look for Denver. So that's right here. So the probability that it arrives on time is 86.1%. Okay. So it's 0.61. And we might want to write it in a sentence, perhaps. Probability that a US Airways flight arrives in Denver on time is 0.61. Given that a randomly chosen flight arrives in Los Angeles, what is the probability the carrier is American Airlines? So given that a randomly chosen flight arrives in LAX, what is the probability the carrier is American Airlines? So first we want to look at LAX. So you can see on top it has the cities here, but LAX isn't here. So we're going to have to scroll down a little bit. Notice LAX is right here. So it's on the next page of table 2. Okay. And it says, given that a randomly chosen flight arrives in Los Angeles, what is the probability carrier is American Airlines? So how many flights arrive in Los Angeles in total? Well, that's 16,924 from the bottom. You can see that. And how many of those were from American Airlines? Well, 2,316 were from American Airlines. Okay, so this probability is going to be the total number of flights that arrive in LAX on the denominator, and in the numerator is the number of arrivals from American Airlines. So the fraction will be 2,316 over 16,924. Okay. I'm going to write that down. It helps to have a piece of paper that we could write these numbers down, and then you don't have to click back and forth. So you can go to the equation editor, and we want a fraction. That's 2,316 in the numerator. That's the number of flights from American Airlines arriving in LAX. And then the total number of flights arriving in LAX. We can get our calculator out and figure out exactly what that probability is. So 2,316 divided by 16924. And so the probability that a random flight that arrives in LAX is from American Airlines is 0.1368. Okay. Chicago has 2 airports, MDW and ORD. If you're flying with Delta Airlines and your primary concern is to arrive on time, is it better to fly to MDW or ORD? So I'm going to write down that we're flying with Delta. So we're flying with the DL. And we want to know which was better for arriving on time, MDW or ORD. Okay. So if you look here, we want to find, you can see DL's right here. So it's this row. And we want to find these two airports, MDW and ORD. Okay, they're not here. Okay, we might scroll down. Ah, here they are. MDW is right here and ORD. Okay, so for MDW, DL, Delta Airlines, arrives on time 91% of the time. Okay. And for ORD, Delta Airlines arrives 88.1% of the time. So if my main concern is that my flight arrives on time, which airport should I fly to? Should I fly to MDW or ORD? Okay, so I want you to explain that here. Okay, so we already looked at the numbers. I want you to explain if I'm flying with Delta Airlines, which airport should I fly to if I want to arrive on time? Okay. Part E. New York City has two airports, JFK and LGA. If you're flying with United Airlines and your primary concern is to arrive on time, is it better to fly to JFK or LGA? So this is kind of like the same as the previous problem, okay? Except we're going to be looking at United Airlines and these two different airports, okay? So we're going to go to United Airlines, okay? That's towards the bottom. And we want to look for JFK and LGA. So I'm going to write that down. We're going to look at UA, JFK, and see, I always forget, LGA. Okay. So I want you to look at the table. Let's see if we can find them here. Okay, JFK is here. LGA is here. And we would be looking at UA Airlines. Okay, so you go ahead and look at the numbers in the chart and figure out which airline I should go to or which airport I should fly to if I'm trying to arrive on time. What gives me the best chance of arriving on time? Okay, I want you to figure that out and type the answer and the explanation here. Okay, once you're done with that, let's go on the next page. Again, if I'm moving too fast, like you haven't finished it, oh, hold on, you could always pause the video, okay? So don't feel like, oh, Tim, you're going too fast, I haven't finished that problem. Feel free to pause the video. Finish answering that one before we move on. Okay. I feel like I say okay a lot. Anyway, questions that are difficult or nearly impossible to answer with Table 2. Many questions are difficult or nearly impossible to answer using Table 2 in its current form. Since computing the answers to these questions is difficult or close to impossible, just give the formulas you would need to obtain the answers to these questions. So in this case, we're not going to be answering the questions, we're just going to be giving the formula you would need in order to answer the questions. So in part A, for example, it says, what is the probability that a randomly chosen flight arrives on time? Table 2 does not give that information. It doesn't give us the information that out of all the flights, what is the probability it arrives on time? It gives you specific, like for specific carriers and cities, but it doesn't give you the grand total. So how would we calculate this thing? Well, it'd be kind of like this. So again, we would need a fraction. We want the probability that a randomly chosen flight arrives on time. So on the denominator is all of the flights, all flights. denominator would be total number of numerator. We would only want those that arrive on time. Number of flights arrive on time. So this would give you the probability that a randomly chosen flight would arrive on time. Pretty simple, I think. Now, and again, the data we have from table 2 does not give us that information. Part B. Overall, which carrier has the highest probability of arriving on time? So we could see which carrier has the best probability of arriving on time for each city, right? So for example, for this city, you could see all the probabilities that are arriving on time. And you could see like Delta Airlines does better than these other ones, but not quite as good as United Airlines, you see. For this city, United Airlines has the greatest probability of arriving on time. But what's the probability for that carrier for all cities, right? So if we wanted to look at American Airlines, what's the probability of American Airlines arriving on time? You'd have to look at all the cities and combine that information. It would take a long time. It wouldn't be impossible, but it would take a long time. So which carrier has the highest probability of arriving on time? For this, we would, in order to figure out this probability, I would need to know the total number of flights by each carrier also. I would need to know the total number of flights that arrive on time from each carrier. You'd have to do that for all the carriers, right? So you would need every single American Airlines flight and every single American Airlines flight that arrives on time and calculate that probability. Then you'd have to do that for Delta Airlines and United and so on and so on and so on. You can see with all that data, with all this data in here, you'd have to do a lot of calculating. Okay. Given that a randomly chosen flight arrives on time, what is the probability that it arrives in Philadelphia? So given that a randomly chosen flight arrives on time, what is the probability it lands in Philadelphia? So do you see where it says given that it arrives on time? Well, that means we would need the total. We would need the total. I would need the total number of flights that arrive on time. This would be the denominator. Wherever it says given that, like before the comma, given that, that's the denominator. It tells you the group you're looking in. We're looking in the group of flights that arrive on time. It says, what is the probability that arrives in Philadelphia? For that, I would also need to know the number of flights that arrive on time in Philadelphia. That would be the numerator. So if we want to put it as a fraction, it would be total number of flights that arrive on time. That's the denominator. Let me go ahead. And in the numerator, the number of flights that arrive on time in Philadelphia. I don't know how to spell Philadelphia. Philadelphia. That would give you that probability. Okay. Moving on. Part D. Given that a carrier is Hawaiian Airlines, what is the probability that a randomly chosen flight arrives on time? So, what would the denominator be in this case? The denominator would be the number of flights by Hawaiian Airlines. That would be the denominator. The numerator would be the number of flights from Hawaiian Airlines that arrive on time. So the numerator kind of takes in both of these to account, but the denominator is always the given that part. This is always the denominator, and the numerator kind of takes both of these to account. So the denominator would be given the carrier is Hawaiian Airlines, so the total number of flights by Hawaiian Airlines, and the numerator would be the total number of flights from Hawaiian Airlines that arrive on time. I want you to explain that here, just like how we did for this one. Okay. Part E. If you're a frequent flyer who travels to many different airports and you have the choice between SkyWest Airlines, OO, I'll write that down, and Southwest Airlines, WN, for your flights, which carrier should you choose if your primary concern is arriving on time? For this one, you would need a lot of information. Firstly, we would need to know what's the probability that a SkyWest Airlines arrives on time. And we would need to know what's the probability a Southwest Airlines flight arrives on time. For the SkyWest Airlines to arrive on time, we would need the total number of SkyWest flights would be the denominator and the numerator. So let's go ahead for OO. You would need something like this. The denominator would be total number of flights from SkyWest Airlines and the numerator would be the total number of flights that arrive on time. What about for Southwest Airlines? It'll be very similar. I want you to finish up this problem. Next page. There's a lot of words here. It says the reason it was difficult or nearly impossible to answer the questions in task 2 is that table 2 isn't quite a two-way table. In other words, there is a total row at the bottom of the table, but there is no total column at the right of the table. In this activity, you'll transform the table into a proper two-way table. So what we need to do is we need to open this spreadsheet here. So we'll open an Excel spreadsheet. and it'll look like this. You want to click Enable Editing right here, Enable Editing. And then you'll be able to change things around. Now, we have this modified table, and you can see some of the data it has directly from table 2 that we saw earlier. So for example, for American Airlines, you can see the number of arrivals to Atlanta, number of arrivals, the number who arrived on time, and the percentage that arrived on time. Or in other words, the probability of arriving on time. And you can see the cities go across the top: Atlanta, Boston, so on, so on, so on. Okay, and it goes all the way down. Now, if you look at this information, they kind of already filled out. You could see for Atlanta, they filled out this middle column, the number on time. So the number of flights that arrive on time, they filled out this column for you already for Atlanta. But they did not do that for Boston or any of the other cities. You can see this middle column is blank. We need to fill out this middle column. We need to figure out the numbers that go in this column. Okay. Right now it's blank, but we need to figure out what number goes there. And I'll show you how to do that. Let's get rid of this. Okay. Let me make sure. Okay. Let's see the way that they figure out the middle column here. Go ahead and click on this middle column for Atlanta, the on time, number on time column, and click this cell. So this cell is C8, C8. So the cell is C8. So go ahead and click on that cell, and you can see over here on the top, there's the formula bar, and it tells you how they got that number. How they got that number. You could see they took B8 and they multiplied by D8 and they multiplied by 0.01. All right, so let me explain what's going on up here. In order to fill out this number here, they took this number, B8, and they multiplied by this number, D8. And then they divided by 100 since this is a percentage. And that's how you got that number. And you could try it out on your own calculator. So I could take this number, 421, and I multiply by the percentage on time, 86, and then multiply by 0.01. If you check that out on your calculator, you should get this value, 362.06. Hopefully you guys can see that there. And that's what they did all the way down. So for this next row, for C9, they took this number, the 29, multiplied by 96.6, and then multiplied by 0.001. And you could see that in the formula bar here. They took B9, multiplied by D9, and multiplied by 0.01. So that's what we need to do in this. So when I want to fill out what this cell is, I'm on F8, cell F8. We're going to take the value in this cell, 809, multiply it by the value in this cell, 83.4, and multiply by 0.01. And that'll give me the value that goes right here. And I need to do that for every blank cell in this column, all the way down. Now, as you could imagine, that's going to take a long time. You're going to multiply this times 0.01, and that'll give you this value. Then for this one, you'd multiply this times 0.01, and that'll give me this value. And you'd do that for the next city, and the next, and the next, and the next, and the next, and all of these cities. That's going to take a long time. So I'm going to show you a trick. I'm going to show you some tricks on how to do this. All right. And the tricks have to do with this formula bar right here. So to figure out what goes in this value, you would take this times 0.01, and that'll give you that. So go ahead and click get back to cell F8. So this cell right here in the top of the Boston middle column. And then click on the formula bar. You should see the cursor blinking right here. To put something in the formula bar, the first thing you need to press is equals. Then click on cell E8. Notice an E8 comes up in the formula bar. Then we're going to do times. At that time, I held shift and pressed the number 8 on my keyboard. You can see there's an asterisk there. Then click on cell G8. So you should see up here equals E8 times G8. And now we need to times by 0.01. And when you press enter, it should give you a value just like that. And you could check in your calculator. If we did 809 times 83.4 times 0.01, notice I get the same answer if you round to the nearest whole number, 670. This one says 674.7, but the 7 would round it up to a 5. Okay, hopefully you can see that there. So round to the nearest whole number, that's 675. Now, are we going to have to do that for all of these all the way down? Well, that would be a lot of work. So now we're not going to do that, and I'll show you what we're going to do instead. So I want you to go back, click on F8 again, where we just put in that formula, and you should see the formula up here. Now, once you have that, you should see, if I hover with my mouse over the cell, you see this big white plus sign. But if you put it in the right-hand corner, you'll see this black plus sign like that. If you click and drag down this column, it should fill in all the values all the way down. So it basically did that calculation for me for all these different flight carriers. And you could always check to make sure it works, right? You could do this times 0.01, and you should get this. And you can see in the formula bar, it makes sense, right? For F11, it took E11 times G11 times 0.01 to get this value. And all the way down. You even want to do this, even this one here. So all the way down. Okay, hopefully that made sense. Now what I think we could do is highlight this column, highlight that column, and we're going to copy and paste onto the next column. So you could copy, then, so you see it has this whole column highlighted now with that dotted line that's kind of moving around. And right click on cell I8. So right click on this cell right here, I8. And you should be able to paste. And it does that same thing. Notice for this value, it took this cell times 0.01, and that'll give you that. Then you would just simply paste again, all the way down for all of these airports. All the airports. Okay, so I want you to go ahead and do that. If it's not making sense, go ahead and rewatch that again. And you're going to turn in that spreadsheet as part of this assignment. I'm going to go ahead and do this very quickly. Since I already have that formula copied, it automatically will allow me to paste all the way across for each city, or each airport, I should say. Whoops. If you accidentally press the wrong thing, make sure to you can press undo, and that'll undo it. Undo is up here. So now we want to do percent on time. Percent on time, we're going to fill out this column here, percent on time. So how do we do that? Well, I want to do the number of arrivals and the number on time. We're going to actually divide that to figure out the probability. So you'll do this value on top divided by this value. And that'll give you the value here. So in our form, again, we're going to click on cell CM8, and go ahead and click on the formula bar up here, press equals, and we want to do cell CL8 divided by, and you could just do that slash there where like the question mark is on your keyboard. Then click on cell CK8, enter. Notice it says 0.9, so it gives me a percentage, but it doesn't really give me, a very good percentage. Notice I'd prefer more than one decimal. So you can actually make the cell show more than one decimal. And the way you would do that is you would use this tool right here, increase decimal. And let's go ahead and click that twice. So that gives us a decimal answer rounded to 3 decimal places. That's very nice. Let's go back to that cell, CM8, and you could see if I put it in the bottom right corner, it turns into that black plus sign. Go ahead and scroll that down. And just like that, we have the percentage of flights that arrive on time for all American Airlines. So for all American Airlines, we now know the percentage that American Airlines flight will arrive on time. And also for all the other flights. It's very nice. Very nice. I hope there are no questions, and I hope that all made sense. And I hope you're learning a little bit about Excel here. Now let's move on to page 8. So now we can answer some questions that we were not able to answer before. In part A, it says, what is the probability that a randomly chosen flight arrives on time? So we kind of talked about this in one of the earlier problems. What information would we need in order to solve this? But now we actually have all the information we need. We have it in that Excel spreadsheet. So what is the probability that a randomly chosen flight arrives on time? So for total flights, the probability arrives on time is 0.863. Easy peasy. So I want you to put that here and explain. Overall, which carrier has the highest probability of arriving on time? Back to the Excel spreadsheet, and we could see each of the carriers. I want you to look through this data and tell me which airlines has the best probability of arriving on time based on this? Part C. Given that a randomly chosen flight arrives on time, what is the probability that it arrives in Philadelphia? So given that it arrives on time, what's the probability it arrives in Philadelphia? Well, how many total flights arrived on time? That's this number. So I'm going to write that down. 259,739. So these are the total number of flights that arrive on time. And how many of these were from or arriving in Philadelphia? So you can look for Philadelphia, which is right here. And how many of them arrived on time? 5404. So your answer would be the 5404 for the numerator, and then 259739 for the denominator. You can go ahead and put that in your calculator, and we're going to figure out what this probability is. Again, this is the probability that if given that a flight arrives on time, what's the probability it arrived in Philadelphia? Okay, 0.0208. I'd prefer if you wrote like this, all this stuff, like more of an explanation and everything, but this is basically it. Given that a carrier is Hawaiian Airlines, what is the probability that a randomly chosen flight arrives on time? So here we want to look for Hawaiian Airlines. And what probability do they have of arriving on time? It looks like the probability of arriving on time for Hawaiian Airlines is not very good. It's 72% or 0.720. So you can see how easy this information is once we have it all situated already for us. If you're a frequent flyer who travels to many different airports and you have to choose between SkyWest Airlines and Southwest Airlines for all your flights, which carrier should you choose if your primary concern is arriving on time? So I want you to look at that information here. Again, we're looking at the OO and WN. All right? And you're looking at the percentage of them that arrive on time. So I want you to go ahead and answer that question and give an explanation there. Part 9. Okay. I don't particularly like this problem, but we're going to do it anyway. Gary Foshi created a popular probability puzzle that goes like this. I have 2 children. One is a boy born on a Tuesday. What is the probability I have 2 boys? I want you to think about that for a moment. I'm giving you some information. I'm giving you the information that I have 2 children and that one of them is a boy that was born on Tuesday. And the question is, what is the probability that I have 2 boys? In this puzzle, knowing that one of Gary's children was born on a Tuesday is as important as knowing that he has 1 boy. Assuming that having boys and girls are equally likely and that births are equally likely on every day of the week, what is the probability that Gary has 2 boys given the available information? All right. So I want you to think about this way. So we want to know what are all the different things that can happen. We know he could have, it's possible he could have a boy and another boy. That's actually what the main thing is, because we want to know what's probably has 2 boys. We could have where his first child was a girl and the second one was a boy. And the third scenario is one of the firstborn was a boy and the younger is a girl. These are the 3 different options that can happen. First, let's talk about these 2 down here, girl and boy and girl. So girl and boy, if this is the scenario, what are my possible outcomes? Well, the girl could have been born on Sunday, and the boy on Monday, all right, the boy on Tuesday. Remember, we know that Gary has a child that's born on a Tuesday and is a boy. So the boy, if you only have one boy, that means that boy has to be born on Tuesday. The girl could have been born on Monday, but the boy, again, has to be Tuesday because we already know he has a boy that was born on Tuesday. The girl could be born on Tuesday also. So it could be Tuesday and Tuesday. The girl is born on Wednesday, boy on Tuesday, and so on and so on. For the boy girl, so I want you to continue this for each day of the week that the girl could have been born on. So Sunday, Tuesday, Monday, Tuesday, 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 Wednesday, Tuesday, Thursday, Tuesday, Friday, Tuesday, and Saturday, Tuesday. So this one should have 7 total options. And I want you to type them all out. For the scenario of boy, girl, again, we know the boy has to be born on Tuesday. So everybody okay if I just put EU for Tuesday? So it could be Tuesday and Sunday. It could be Tuesday and Monday. Again, the boy has to be born on Tuesday, right? So the boy is stuck going with Tuesday. It could be Tuesday and another Tuesday. Tuesday for the boy and Tuesday for the girl. It could be Tuesday and Wednesday. It could be Tuesday and Thursday. It could be Tuesday and Friday. It could be Tuesday and Saturday. Okay. So again, 7 different options here. So for the girl-boy option, 7 options. For the boy-girl option, 7 possibilities. So 7 possibilities here, 7 possibilities here. What about boy then boy? Well, we know one of the boys has to be born on Tuesday, but we don't know if it's the older boy or the younger boy. So it could be Sunday and Tuesday. It could be Monday and Tuesday. So on, so on, so on. It's all of these the same as down here for the boy, girl. So I'm just going to copy and paste that here. Sunday, Tuesday, Monday, Tuesday, 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 Wednesday, Tuesday, Thursday, Tuesday, Friday. Oh, wait, I messed up. I don't want that one. Get rid of that. I need these flipped around, huh? Yeah. Let me go ahead. I'm going to erase all that. And I'm going to put in all of this. So let's assume the first boy was born. First boy was the one born on Tuesday. So it could be Tuesday, Sunday, could be Tuesday, Monday, could be Tuesday, could be Tuesday, Wednesday, Tuesday, Thursday, Tuesday, Friday, Tuesday, Saturday. But those aren't all the options in this case because it's possible the younger boy is the one that was born on Tuesday. So it could be Sunday and Tuesday like that. Instead of Tuesday, Sunday, it could be Sunday, Tuesday. It could also be Monday and Tuesday. Can I write Tuesday and Tuesday again? Well, I shouldn't. I shouldn't type that again because I already have it here. See, Tuesday and Tuesday is the same as Tuesday and Tuesday. So that's the same thing. I don't want to count it twice. So let's get rid of that. But it could be Wednesday and Tuesday. It could be Thursday and Tuesday. It could be Friday and Tuesday. It could be Saturday. Notice how many options for boy, boy there are. Let's go ahead and count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And how many options for girl and boy? Well, there were 7 for this first and 7 for that second. So in total, we have how many different options in this sample space? Well, it would be 27 different options. The 13 from the boy, boy, and the 14 from the having a boy and a girl. And how many of these options have a boy and another boy? 13. So actually, you would think it'd be a 50-50 chance, but with the information that you have a boy born on Tuesday, the probability of having 2 boys is actually less than the probability of having a boy and a girl. 13 out of 27. This is a probability of 0.4815. I hope that kind of made sense. But yes, the probability of this person having 2 boys, in this case, is less than 50%. And that's it. That's it. Well, I hope that made sense. If you're having trouble answering some of these questions, if something's not making sense, you want me to explain it more, maybe the spreadsheet's not working, something's not right, feel free to email me. My email is ttrigg@ofy.org. Again, that's ttrigg@ofy.org. All right, well, with that being said, farewell, and I'll see you guys next time.